morning, everyone. Welcome to the Arola Laboratory of Advanced Material Processing. This is our main laboratory in Roberts 204. Here we have a variety of computer and printer setups so you can come and do your work, both research and class related. In the Arola laboratory, we have a number of mechanical testing frames. This one is the Endura 3200, and we can use this to test small plastic tensile bars. In the Arola lab, we're always acquiring new technologies to complete our research, including this new wire saw cutter. We use this to cut ceramics, enamel, and other biomimetic projects. And this is a 3-roll mill, also used in our ceramic projects. Here we have a digital image correlation suite where we can capture real strain of any sample. Here we have our slicer grinder with a diamond saw, and we use this to section teeth. Here's our laboratory fume hood. We primarily use this for mounting our small epoxy samples, which we then polish, but we can also use it for mixing small solutions. We also have a scale as well as a hot plate and a sonicator, and we use these for sample preparation. We have a small low-speed saw which we use for sectioning titanium tensile bars. And moving forward, we also have our polishing system. There is an additional polishing lab in Mueller, but we have this small-scale laboratory one for our use. This is the second lab space operated by the Arola Laboratory. We share this room with Dr. Flynn, also in the MSc department, but this location houses most of our 3D printers that we use. Here on this table, we have our polymer and composite 3D printers. So we've made modifications in adding a new temperature controller so we can go up to 400 degrees Celsius. In addition, we took this extrusion motor, which was in the nozzle head, and we moved it up here so we can better control the deposition of composite filaments. These are our marine aging baths. We use a saltwater blend to age tensile samples. This is a small plastic TPU tensile bar printed on our 3D printers that will then be aged and tested for water retention, water degradation, as well as tensile properties. Located in the basement of Wilcox, we have 2 Instron E1000 mechanical testers. With these devices, we can test tensile bars in these grips, as well as 3 to 4 point bend. We can also design our own tensile grips to meet our experiment needs. Currently, we are using 2 clinic load cells, but we also have a smaller one in addition.
Welcome to one of our 3D printing labs. Here we turn titanium powder into fully printed titanium parts. Behind me is a EOS M290. It is a selective laser melting machine, so that just means that it's printing by selectively melting layers of metal powder using a laser. So on my right here we have a couple of pieces of equipment that are used for recovering powder that's not melted during the 3D printing process. And powder recovery is a really important aspect because it's the raw material and it's incredibly expensive to purchase and to manufacture new powder. We do a lot of cool research here involving kind of the fundamental science involved with 3D printing metals. So we hope you can join us here.